Hello class. So welcome back to another lecture on disaster management, and we will be continuing where we left off on hazard. In the last time we were talking about different paradigms of hazard and how hazard as a terminology has evolved over the time. And today we'll be talking about some indexes or measures to assess those hazard. So generally they are different. We know that there are different natural types of natural hazards existing in the world, but they have some commonalities, some common dimensions, or you can say an indicator or measurable measures to assess severity or magnitude of a particular hazard. So before we begin, let's talk about that. How do we identify which hazard is there? What type of hazard is existing in the society? What sort of hazard we can think of? So are living in a very hazardous environment in which we are exposed to so many known and unknown threats which can have an adverse impact upon your life. uh, so now it raises a question, why do we need to quantify hazards now? In the last decade, natural hazards have accounted for a large number of deaths accompanied by several billions of dollars in damages. And while these damages have increased, we have observed that might be related to more improved methods of reporting or documentation. But nevertheless, natural hazards and their negative effects have continued to rise, partly in effect of climate change, but also due to development associated factors like rapid urbanization, population growth, environmental degradation. So, which raises a question that hazards are there and what sort of impact they might have. So some hazards are easier to predict than others. For example, volcanoes normally give warnings before erupting. Tropical storms can be tracked down, but as compared to earthquakes or landslide, which are very harder to predict. So generally speaking, hazards with no warning are going to be very more serious. Okay, and because these different types of natural hazards, they will have different characteristics. Okay, so they will differ also in terms of impacting or threatening human life. For example, since floods are characterized uh, by rising water levels, the risk to individual and objectives and systematic and systems can be potentially reduced or sometimes even be altogether avoided with proper precautionary measures, as opposed to quick landslides or earthquakes, which really give any warning signals. So that raises a question that points out to the fact that what are the event parameters and what is hazard assessment. So hazard assessment, sometimes also called hazard identification, when we don't know, we are trying to identify what sort of hazards are existing in our society. It is a past, it is a part of the process which is used to evaluate if any particular situation, individuals, or society may have the potential, may be exposed to the environment which might cause him or her harm. So, natural hazard assessments are becoming increasingly important for the design of policies and improving disaster resilience and promoting adaptation in the light of projected natural hazard. So, the first thing, these are some common parameters, and they have there are some people have characterized it differently. So generally, these are magnitude, likelihood, frequency, and duration, and they have scientists have used maybe some similar words to describe these characteristics. So the main one which comes to the mind is the magnitude. So if we define a natural hazard, the definition of a natural hazard, it is an unexpected or an uncontrollable natural event of unusual magnitude that might threaten the people. So what it is basically strength of a hazard. So magnitude Now, as a strength of a hazard, it can be measured, and it should be measured according to a particular scale. So, for example, Richter scale is used for the earthquake. So, higher the Richter scale earthquake, higher the value on Richter scale, higher is the magnitude of a particular earthquake. The volcanic explosivity index, it denotes what is the potential, what what harm can it do. So generally speaking, the stronger the hazard is, the higher the magnitude is. So it is also sometimes called as severity. Okay, so severity or intensity of hazard can be defined into an escalation of a phenomena into different classes or categories like mild, moderate, severe, extreme. Now these are usually determined through indicators or indexes, uh, and these indexes include origin, force, speed of onset, damages, and the spatial effects. So, one of another method or a definition of a magnitude of a hazard is basically event which have generated a lot of energy. So, intensity and these things. Now, this magnitude, intensities, or severities, it also depends upon the spatial factors. So, so the another quick relationship between magnitude and frequency is that we've talked about extensive and extensive risks, and the analysis of historical records and their frequency have enabled scientists to understand when a certain hazard with a certain magnitude is likely to occur. And it is generally it is accepted in the scientific community, the frequency of events with low magnitude is high, and while the frequency of events uh, of of the frequency of those events, the high magnitude events, the frequency is low. Okay, so onset. Okay, I'll go into the. Okay, let's talk about the scale. Okay, so this is a magnitude scale which defines your earthquake magnitude. Okay, another component of magnitude, or you can say index measure, is the onset. It is basically beginning of a hazard, and it, like we can say the if the the beginning of this hazard can be assessed through modeling or indicators or indexed to reaching of a certain threshold or value. Also, it also depends upon the place of origin and how much quickly it reaches to the community. So if the peak of the hazard arrives first or arrives quickly, then it will more likely to have worse impacts as compared to other hazards which come slow. For example, earthquake has a fast onset, or you can say a rapid onset. They occur very quickly and with little warning. And on the other hand, slow onset hazards, they occur very slowly and may take days or years to develop, like uh, insect infestations or droughts and some kinds of floods. So slow onset and rapid onset. So there are two different kinds of onsets. So that also determine your warning time. The more rapid it is, less time of the warning. So different hazards have different rate of onsets. So they would have different hazard characteristics, and they will affect, or their potential threat to communities will vary. So earthquakes are with sometimes flash flooding. They come. They have very little warning. Tsunamis come sometimes give minutes or hours, and hurricanes might, depending upon hurricanes and river and floods, basically, it would take several hours or days. If we have good predictive modeling, we can have or we have better hydrometeorological data and stations, then we can have days some good warning time. Okay, and Some volcanoes, well, it is like it can erupt suddenly, but it can also kind of give a long time to erupt. And deserts, sorry, drought and desertification, that generally takes uh, periods of months or years even. So here is a rough scale, or you can say a time set onset of different hazards in the world. So which vary from seconds to minutes to hours to days, weeks and months and maybe years as well. Damages. Now, damages, okay, to assess a damage or to assess hazard, we are doing a hazard assessment before it has happened. So damages are assessed, or threat or severity is also assessed using what are the potential damages a particular hazard can cause. Will it be catastrophic? Will it be major or moderate or minor? Or how much severely some people can be hurt? So this is another scale or a method to a certain hazard impacts. Okay, so this is basically different types of damages which have incurred over some different uh, natural hazards as well as some different areas. So you can see Asia and America's region, like particularly South America and Asia, which we call global South, have experienced a lot of economic damages, and the most damages caused, or you can are the hydrometeorological disaster like flood and storms, which have caused a lot of damages to the world. Another is your likelihood. How likely is it to occur? How what is the likelihood of occurrence of a particular hazard? So that likelihood, when will it return? When it might happen again? That also links to the hazard's severity, or you can say hazard intensity or hazard value. So magnitude, likelihood, they will work together to form likelihood and the possible impact. Like they would likely develop what sort of impact a particular hazard might have. Okay, so higher the probability, higher will be there is a relationship that severity of hazard and the risk. So hazard has a direct relationship with risk as well. And when we include probability and hazard, we might have a method to assess risk to certain disasters. Another is frequency, how frequent it is. So it is time bound. So is it cyclic? Is it recurrent one? For example, is it happening every year? Is it happening uh, every 2 years, every 5 years, every 10 years? Is it a cyclic phenomenon or is it non-cyclic? For example, some floods, for example, are cyclic, like in Pakistan, monsoon rains cause disaster frequently, and every monsoon we have some kind of flash flooding, and in every summer we face river and floods in late September. So cyclic events are there, so their recurrence level are there. There is a return period. We'll talk about return period in the coming slide, and then what sort of factor does the frequency uh, is it two times, like in the what is the impact uh, in the morning on the night? So some different factors are there which might affect the frequency of disasters. So coming to the point of return period, let's talk about return period. So imagine a coin. If you are like spinning the coin and you want heads or tails, so depending upon how many time, what is the probability that heads will come again and again? So what is the probability? So this is just like in disasters. So we are going to be predicting disasters. We're going to be predicting hazards. So we know that hazards or disasters are unstoppable if they are of huge magnitude. So the best way is to get out of its way. But we need to have accurate measurements to assess when will the next disaster or next hazard will occur. And those events that occur at predictable intervals are called cyclic events or recurring events. Okay, now sometimes because of uncertainty and so many unknowable or unknown variables at play, that some kind sometimes make it some them non-cyclic. So they are very much we cannot prepare for them because we cannot predict, the model cannot handle them. So one is cyclic. So now when will they occur? So that in terms we call it intervals. Are the interval levels same? Will it have every 6 months, every 2 months, every, let's say, 1 year, 10 year, 100 year, 50 years? So we are going to be predicting catastrophe in terms of, in a certain area, when will a hazardous event occur? What would be the temporal range of it? But within several decades or years, hundreds of years, with approximate percentage of probability or certainty that this flood will occur. So it's so they are usually measured in human time scale. For example, 5-year-old flood, 5 year flood with a 5 year return period, a flood with a 50-year return period, and a flood with a 100-year return period. So basically, we are going to be measuring the magnitude and intensity and when will it occur. So we are going to be so how to explain it? Like, let's give an example of flood. For example, a recurrence over of 100 years, a flood which will come back in 100 years means that in every year it has of a certain magnitude, it has 1% chance of occurring. So uh, events with low frequencies but high magnitudes have destructive capacities, like rise of intensive and extensive risk we talked about. So extreme events with low frequency generally have higher magnitude, and that would result in very extensive damages. Another point, another which also means that a 100-year flood would cause more damage as compared to 5-year flood, because 5-year flood, a flood which is coming up every 5 year, has lower frequency and probably will have very low magnitude, and therefore it would be less destructive as compared to a flood which will come in 100 year. It will return in 100 year. So talking about some different return periods, we can see that floods are occurring. So this is a basic trend of flood, that how much rainfall or how much rainfall is happening in a particular year in a particular area. So average rainfall is spread out, and we can ascertain that in some years there will be no there will be below average, very below average rainfall. So that would result in kind of 3 year drought period. So but if it average rain is too much every year, then that might cause a wet period. But if we have put a certain threshold, that if the rainfall exceed a certain limit or a certain threshold, that will be termed as flood. So this flood is occurring, and this is the return period. This is all the it has returned after so many years. So that might result in that. So now talking about this return period, and in terms of, especially in terms of earth floods, different methods are there to assess that, and we will be talking about this in the coming lectures on flood hazard assessment. So we will come back to the return period, and you might have more understanding about it. Then comes the duration. So another point to measure a magnitude or a severity, or you can say a hazard value, is how much time did that hazard stayed in that area. So particularly for floods, it is number of days or hours or time which the water has stayed in the house, roads, or in the agriculture fields. So duration of the hazard. existing in a society that also corresponds to very high risks or damages that are associated with that. So, now overall, coming to the point of hazard assessment, the governments around the world are in like it's their duty to do hazard assessment in the area for safeguarding their citizens. But generally, in the developing countries, especially, the governments are not so enthusiastic, or they are not so much proactive. They have more pressing issues at hand, which you can say restricts them to think proactively and work out some disaster risk reduction in advance. And those countries, developing countries, they are having financial constraints which limits them to prepare for disasters. And then it points out then how are they going to be assessing the hazard. So there are different types of assessing a hazard. So first of all, the most authentic is to look at the scientific and statistical data of past hazards and determine when it will occur. Then is your historical records. You might extract information from these assessments, and we might uh, let's say in particular events which has happened in the past, and we might look into them and we can have some records. But now these records are important in developing and understanding the present and future hazard. But these catalogs can stretch back hundreds of years, with researchers can comb through the historical document and estimate the characteristics of distant events. But these records only go back a few decades, and they are like arguable that are they were they precise observation and measurements. But often they are not complete, but they are still, or sometimes even not reliable, but they are a useful source of information where in the absence of other data, uh, we can use them as an inputs for a more robust natural hazard assessment. They can help us uh, like estimate some return periods of recurring events, calibrate our models, and identify the geographic areas of particular concern. And historical catalogs that cover long time periods, wherever reliable and if they exist. Historical records are relatively limited uh, periods of time, which often report only high impact events or low frequency impact events. So uh, now they can be like underestimated or underreported, but still we can find records in those historical documents of some events, some powerful events or high impact events. Then approach maybe some indigenous people over there, and they might help us in understanding the various intensities of the same hazard, and that would eventually leave us to the final product of hazard assessment in terms of mapping. So, no mapping or spatial extent or aerial extent of hazard. Hazard is spatial. You can say extent is basically an inherent part of natural hazards. Like natural hazards are inherently a spatial phenomena even. So the it this aerial extent varies in time and delineation of these parameters in various areas. For planning perspective, the spatial characteristics of hazard is important because it will help us in understanding the dynamics of a hazard, how it react, how it will impact particular area. So location is a very important part of natural hazard assessment. So due to the spatial character of these natural hazards, maps are commonly used to provide some visual depictions of hazard information. A key component of natural hazard assessment relates to develop understanding how hazards vary across the space. As a result, the majority of natural hazard data is available in this GIS format, so spatial formats. And remote sensing or GIS are critical tools for creating, analyzing, and communicating spatial information about natural hazards. Uh, Now, for example, uh, earthquakes are happening along the plate boundaries, so we might be able to locate or we might understand the hazard dynamics near those plates. So, this hazards and this spatio-temporal dynamics, they have a very close association with each other. And now the process of collecting all this information, this magnitude, this duration, all these different factors or indicators, these are some generic indicators or generic parameters, dimensions, characteristics. And this process is basically collect, consolidating this information is basically the hazard assessment. So hazard identification again. So hazard, also called identification is like if you're living in an area, what sort of hazards are there? And if they are there, are they significant to threaten your life? Does these threats recurring? How many people will be affected in your opinion? So what is the expected duration? What is the expected damages? What is expected intensities and the predictability? And so based on all those different factors, if for, we count, we incorporate them in our models, we can estimate or we can have a very good hazard assessment model in which certain areas will be at high hazard and certain areas will have low hazard. So here is another select parameters for uh, selected hazards in which there are different measurement units to assess level of the hazard of different hazards, cyclone, earthquake, flood. So they have different measurable units and how to what are the threshold limits which will define that this hazard is now become life threatening or not. So this is hazard different characteristics of hazard assessment. Thank you for joining the lecture.